Good morning everyone. Today I will be introducing SSH, which stands for Secure Shell. Secure Shell is a cryptographic network protocol used to secure remote login and other network services over an unsecured network. It essentially provides a safe channel for communication between two devices, usually a client and a server, by encrypting the data being transferred. Developed as a replacement for older, less secure methods like Telnet, SSH has become a standard for system administrators and anyone needing secure access to remote machines. SSH was born in 1995 when a Finnish researcher responded to a campus password sniffing incident by designing a protocol that encrypted remote logins. His work laid the foundation for SSH rapid adoption. It replaced insecure logins and telnet sessions, becoming de facto standard for protected shell access and secure file transfers. That initial motivation in countering credential theft still underpins SSH enduring impact on network security. At its core, SSH provides a secure, reliable channel over an insecure network, guaranteeing that data sent between client and server remains confidential and unaltered. Organizations that adopt SSH protect sensitive information and upholds the user privacy. Beyond remote logins, SSH versatility extends to secure file transfers via SPF or SFTP and even tunneling arbitrary TCP connections. In today's threat landscape, implementing SSH is no longer optional but essential for safeguarding communications. Now let's take a look at architecture of SSH. SSH operates using a client-server model where the client initiates the connection and the server responds. The connection process generally involves three major phases. First, the host authentication, where the server proves its identity to the client. Second, the client authentication, where the client provides its identity to the server, often through passwords or SSH keys. And finally, the encrypted communication, where both parties securely exchange information. This layered structure ensures that data remains confidential and secure at every step.
Here are some essential SSH commands to get started. To log in remotely, run SSH user @hostname, manage your key pairs with SSH keygen to generate keys, SSH agent to hold encrypted keys in memory, and SSH add to load them. For transferring files, use SCP source destination for single command copies. Now we'll look towards to understand SSH in OSI layer. In network models, SSH operates at the application layer 7 of OSI stack. Using TCP at the transport layer, all SSH traffic rides over port 22 by default, ensuring reliable streams. Conceptually, SSH sits above the core TCP IP suite where TCP handles packet delivery. SSH builds an encrypted channel on top, wrapping your data so that even if someone intercepts the packets, they cannot decipher the contents. Understanding the workflow of the SSH protocol. SSH powers many real-world workflows. For example, GitHub relies on SSH keys to authenticate developers, pushing code, ensuring repository integrity. System administrators depend on SSH every day to manage Linux servers remotely, no password in flight, just public key authentication. A typically workflow generates a key pair locally and places the public keys on the server. Thereafter, SSH decrypts the session with your private key, granting you secure shell access without ever exposing your credentials.
Okay, so we will be going through the applications of SSH. So SSH is a protocol for encrypted network communications, and it lets you log into remote machines via and execute commands and transfer files safely. Unlike FTP, whereas you can read every keystroke of the data that is being transferred. So SSH uses a cipher, it encrypts your code and your data with ciphers. Tools like SFTP. Users authenticate via passwords or more securely over with public key pairs. Commands run over SSH inherit its encryption. Also, even simple tasks like directly listing remain protected. Whereas unlike Telnet, where any attacker can monitor your data transfer. And after that, we'll be going through some SSH alternatives. Some SSH alternatives include Telnet, which allows remote access but lack restrictions. There is RDP, which provides a graphical interface for the users. SSH2, which is a major improvement over SSH1, offering better encryption and authentication methods. OpenSSH, which is widely used and it is the most popular form of SSH. Telnet, which is less secure though, and RDP enables users to connect with another computer visually, enhancing visibility, but SSH2 enhances its security. OpenSSH, which is an open source implementation of SSH, provides secure communications over unsecured networks. So, real-world applications of SSH. What does real-world application of SSH are? First is GitHub Secure Access. GitHub employs use SSH protocols for secure access to repositories, enhancing security for developers. Let's walk through a quick SSH session workflow. First, the client opens a TCP connection to port 22 on the server. After that, the server presents its host key. The client verifies the host key, and then to prevent some man-in-the-middle attacks. After that, both sides perform a cryptographic key exchange, often via Diffie-Hellman method. After that, a public key is authenticated via the client and the server, which at this point the secure shell gets opened. You can run commands, transfer files, and get protected them and encrypted them under various ciphers like AES. In conclusion, SSH or secure shell is a highly encrypted and highly secure way to transfer files, way better than the file transfer protocol. And we sincerely appreciate the participation and interest in our presentation, and we conclude our CN presentation with the network routing protocols, and which is our topic SSH. Thank you.